All right, so we are here today to hear this gentleman, Reino Reiner.
Exactly.
I'm really bad with names. He is a Docker captain and a software delivery automation engineer at Pipedrive. Fun fact, he is also, his hobby is circus stunts and doing aerial silks from like 8-meter silks. I want to see that, so just forget this presentation altogether. So you're all here. I'm sure you're probably developers. This is a conversation on Docker for developers, a day in the life of a developer at Pipedrive with Docker Enterprise.
All right. Thank you for coming here. So maybe if we have the time, I can show one of my performances from YouTube. But I have another fun fact as well. So I joined Pipedrive 4 years ago, and the main reason why I was hired was that I was brave enough to use Docker engine for production workloads and for databases, which were big no-no back then. And nowadays, nobody remembers that Docker is supposed to be only for development and testing environments. But after, if we got over this issue, we started to add our new services to Docker environment. And we didn't start using Docker Enterprise. And a lot of things, if you are following my slides, you can do actually without the enterprise at all. So what is Pipedrive actually? So we are quite a small company with 500 employees and 200 are engineers, and we over the past we have managed to build 400 micro or macro services. So I believe that in the future we're gonna drop micro and we are just services. At least that's how I see. It's like a digital camera. Nobody says anymore digital. It's just a camera. So, and we run in 3 data centers. One is on the soil of US, and as we need to be GDPR compliant, when at least 2 of those are operated in Europe. And we have 8 clusters deployed for various use cases. So 3 of them are live workloads when we have staging environment, and I'm going to also talk about our on-demand sandbox environments, and we have actually dedicated 2 clusters to meet those workloads as well. The first thing, what maybe it's not very common, but at Pipedrive we are using Docker to actually separate the duties. So usually what the developers do, we build new features, but we have given authority and the responsibility for availability as well. But with great power comes great responsibility. So we have found several ways how to extend the Docker Enterprise or this entire ecosystem with different tools. So it's, I would say it's good to get up and running, as you have seen several keynotes, the demos. But if you go on this scale, as we are running quite a modest number of 400 projects, which actually are almost 600 services in production, then it's not enough to use all the functionality what Docker has. And what operations people do, they actually make sure that clusters are up and running and there is enough capacity. And if there are some patching needed, well, at least they are not involved to ask any downtime time. So using the Docker technologies, it's very simple to keep those roles divided like this. So I'm gonna do quite a lot of demos. I'm gonna switch a lot of windows. So pay attention. I try to explain as much as possible. And my purpose of this talk is to deliver one service to live environment. So this is Pipedrive web service in live, and I have standalone web application DockerCon 19 running here. So, and I'm gonna show you very simple example. I'm gonna update with the team and make this button blue and go all those steps what we currently require to do. So first of all, I'm gonna show you. It's look all empty except that I have one app running. I'm gonna remove everything so that it's all fair, like magician. Right.
Is there enough contrast?
Yes, please, thank you.
So let's see. I think it's, I can. So can you see enough? I can also, is it visible for you? All right. So, first thing, 4 years ago, there wasn't any Docker app or Helm. So we had to invent our own package management system. So, and what we did, we took Docker Compose file and we wrote this very simple bash script. At the first iteration, versions 1.0 or 0.1, don't remember what we called it, but what we had was like 100 shell script and one Docker Compose file. So as we got more services running as microservices and using Docker as a backend, and of course, quite a lot of them were mandatory, so that it's possible to do any kind of development locally at all. We created more packages. So what it means, we added just more Docker Compose files and wrote some wrapper in shell. So it's the only repository using Bash as a primary language, and today, last time I checked, it's 5,000 lines of code. So I have really high expectations that the Docker app gonna take the heavy lifting and make it more simpler today. And so today, for locally, we require, I think, some 15 services, and for example, what is maybe not very common is we use external service discovery console. So, and I think it's one of the best decisions so far. It means that we have managed to combine traditional environment using VMs and containers all together using single service discovery. All right, it's coming up. Took some 2 minutes. The previous solution was using the Vagrant machine, and it took like 30 minutes to provision. So let's see. It's a wrong tab. So Pipedrive.works is actually a local domain. So it's coming up. So let's see if my demo service is running, and it's supposed to not run, but we are hiding the errors anyway. So I got my environment up and running, and as you see, it was using very simple Docker Compose script. You can provision the development environment quite fast. So next to the next demo, I have a Node.js service prepared. So this project is using our template. So we have the Docker files, when the Docker Compose to get it up and running locally, and several JavaScript related files. And as I have already installed libraries in advance, so all what I have to do is to run the Docker Compose up. And it's coming up, and it's... So... And... Give me some time for service discovery. No, it's not working. Compiled. All right, it's coming up. So here it is. So my task is to make this button to blue. And I'm not the daily developer, but for this server, for this demonstration, I just learned something. So this is very simple, and I just set it to blue, and voila, it works in my machine. Now. I have ensured that code is running, but does it actually run outside? So today we require that at least it has to be validated somewhere before going live. So I'm gonna commit the code. And I want to be sure that it works, and I don't want to disturb any other fellow colleagues, or another thing is that maybe I want to demonstrate it to some other colleague in other area. So, and that's why we created on-demand sandbox environment, and we extended with our own UI using the Docker as a backend. And let's go to here. So I have prepared one test box. So what it is just a list of services. And if I need to create another one, I can just tell. So here, so it belongs to my team, so people know to whom to ask. And there are the different kind of templates. So I'm gonna make that the default one. And in the background, what happens, if I go back to this slide, is that we use Docker's form as an orchestrator instead of Kubernetes, as quite a lot of companies do. And we found that for simple orchestration and giving the responsibility to manage Docker services, it's the learning curve is very simple. And we have grouped services under the Docker stack. All services connected to overlay network altogether. It is for us. It means one sandbox environment, and we internally call them the test boxes. And of course, additionally for Swarm, there is quite a lot of support tooling that we use Jenkins for the building and the deployment, or gray log to save logs. And for example, if you have quite a lot of services, for example, using internal logging mechanism can be quite overwhelming. So if you configure a Docker engine to send all logs to log aggregation, you can do quite a lot of interesting stuff that you can actually search or do some quick statistics and troubleshoot it internally. Another interesting feature what Docker doesn't promote, but usually with the enterprise there is by default Prometheus instance running in web background, which is protected by TLS-based authentication. So you can either scrape the data from Prometheus or deploy your own Grafana and build more advanced dashboards. And we have additionally added some more metrics to what we know when the deployment was created. And for example, last 24 hours I have practicing a little bit. We can see how much memory or CPU does it take. So back to the test boxes. So I need to test it out. And here is my missing tab. Now, I'm gonna use previously created test box because I have created the test data there, and I have added my Dockercon service here already. But what I want to do, I want to go and deploy my demo branch here and see how it works here. So I just click save and redeploy. So, and what happens now? So previously, when we started to use by creating pipelines, there wasn't any multi-stage builds available. So we created some quite a complex custom Jenkins jobs to have minimal images, to have caches in place. We don't expect that every developer is a hero of the Docker and understands how it works. So we also have our own validation step as well, which I will show what kind of report I get when I go to release to live. So, and for example, you can see that the dependency install took 1 second, but actually it was just validating that the cache is valid. So we have node libraries present. So it should be, we are almost ready to go to validate. I'm gonna go and check it out. It's that tab here. For now, I expect. Oh, and as I did with service quick and dirty, and if you somehow if you are a Pipedrive customer and want to validate it, then slash is actually mandatory here. So today it's still green, and let's see how it goes in test box manager. So it's still deploying and it says failed. Oh no. But actually it was expected. So what is not expected, I need to go to that service details. Not that all right, I will go old-fashioned way. So as I'm the developer, when we have granted access to all UCP instances with limited rights, but necessary to go and find various services what we have deployed. So let's go and find my stack, which was actually I have a shortcut button as well, but because I'm so deep Docker person, I'll usually use it from here. So, for example, where is a shortcut button so that we don't have to memorize where service is running. As we have like 2 clusters, we can go and find it conveniently directly from here. So it's a little bit slow, but it will come eventually. So what happens if I can't put a sticker on here to make a sacrifice for demo gods? So what I want to do is that I need to go and investigate what is actually happening here with my service. So I guess it's gonna take a while. But as I also love to use Docker bundle, what I can actually do is and hopefully it's much faster. Right. Gonna take some time. It's still 2,000 services. Let's see. Still coming up. Waiting. Waiting. All right. So I have it here. It shows what I wanted to show you before from a web user interface was all right. So where is the pause? Failure action. No, I need to show you something else. So it's actually up and running about an hour ago, but it's not true. And probably my Jenkins job failed. That's all right. As a developer, I also have access to the Jenkins job, and I can go and look what is happening with the build system. So it failed. I can go and check all the logs, and usually there is an error in the end. Invalid memory value. There must be at least 4 megabytes. All right, fair enough. Let's go back to my demonstration again. So we used the Docker Compose files to run it, and here it is. Oh my God, I set the memory value too small indeed. So I'm gonna fix this issue immediately. I'm gonna set it 16 megabytes. And I'm gonna set the limit to 1 128 megabytes. So what I actually expected to show you was that I'm hitting the resource limit issue, not the reservation memory issue. All right, so let's go and now, because I know that I've fixed the Docker Compose file and the Docker image is exactly the same, I can use the previous the Docker tag and go and redeploy again. So using that demo revision branch and same the Docker tag. Now it should go much faster as we are skipping building the image. All right. So, and one of the things what we do is that every time when we build the image, we create the unique tags. So, because we build and deploy so many times that it doesn't make sense for us to make some specific release tags like version 1 and version 2. So what we want is that revision and that build, we know it has been tested and worked last time, so it's very easy to roll back to the previous version. Right, so it should finish soon. So I can go and see. So it runs previous things. One thing, when using Docker Stack Deploy, is anybody else using Docker Stack Deploy with Swarm? Not at least I don't see. But there was one thing, you can't use it out of the box in CIs because it doesn't do any reporting. And we had to build our own agent which goes and pulls the data from Docker Swarm and verifies if the deployment was successful or not. And we built internally for our agent, but there are open source agents available. All right, so we managed to deploy this service. I'll close that one. This one never opened. So, and finally, let's do a refresh. So it is blue, and all what this button does is I currently show some specific container environment. So it's running in our testbox 4, its container ID and what the build was deployed. So now I have proved that now it works outside of my machine as well. And let's do the release. So, and to release the code to production, I'm gonna start it. So is that assuming that I got the review accepted, all what I have to do is I add ready for deploy label. And we send out webhook, our container orchestrator starts the deployment. Now it's gonna take 6 minutes. I'm gonna explain why we need this kind of container deployment orchestrator at all. So Pipe process I developed locally, worked fine. I used some sandbox environment which were isolated so that when I deployed this microservice even it was almost broken. I got the feedback very quickly. But as I told you before, in Pipedrive we have 8 clusters and 6 of them are combined together are staging and production. We need to have a staging and production environment as closely similar as possible due to various reasons. For example, infrastructure people also were testing where changes were. And when I add this label, we go through the different cycles. So we scan always configurations. So my fellow colleagues were writing master thesis, what I'm supervising, and hopefully there will be open source tool available where you can actually describe the rules, how to set up Docker containers. There are a lot of bits and pieces available on the internet, but my colleague is trying to automate this part. So we go and scan those configurations, and of course we have enabled several testing practices. So we have 3 layers of testing depending on the use case. Does it make not every service has the 3 testing layers available, but for this demonstration, it was nice to have some green boxes. I created each one of those. So assuming that all tests are passed, the service is running in the staging environment, we go to production. So, and little bit about the numbers. So 2016, we didn't use the Docker at all. So we had big monolith, very traditional best practice available back when, and some couple of services. And back then we were at 25 people, but it was already a challenge to coordinate how we release our changes if everybody are modifying the same code base. So 2017 in January, I remember it took like 6 months to get the first Dockerized service into production, and using the experience and also together with microservices, and we got funded with some millions of dollars. It also helps. We hired more developers. Like by the end of the year 2017, we were instead of 50 developers together, and I believe it was also about 100 microservices what we created, and we did altogether 50 deployments. And I think it was like 10,000 deployment to live environment. So we are tracking all our changes. And I don't remember how many failed deployments we had, but this was also a big number. So we got more funding. We got more money to hire more developers. So 2018 we were like about 100 something, and we got 250 microservices when. But what is interesting is that why it's increasing so much is that we also enabled sandbox environments. Before the sandbox, everybody were using staging environment for the testing, and it introduced quite a lot of issues. That if somebody wanted to test if a change does it work, or some A/B testing when there was always competition. Now adding those sandbox environments, which pretty much is automated environment orchestrator, it increased the number, and we did it like almost in the end of 2018. So, and how it influenced? So the last time I checked, like 1 day ago, yesterday, we have all, with 4 months or 5 months, we have already passed the number of for last year. All right, let me go and see a few more things. So, as I said, we don't expect that everybody knows what are best practices, and I got some notifications that some health check configurations should be higher. It was, we introduced this policy because when we deployed like 50 containers into a live environment, the health check started to fail with previous version of the Docker engine. It was 17.06 when, but luckily this is now all solved. All right, I believe so. This went through all the stages, updated 47 seconds ago, and if I go to live, and this is not the live environment, for example, this one, it's a good time to brainwash with Pipedrive pipelines, and DockerCon 19, and it's the blue button, and you can see it's running in US East. All right. So just to wrap up, in Pipedrive, we used the Docker. So we are using an enterprise edition, but we started with open source components only. We divide the responsibility between operators and the developers. So we managed to get the agility boosted quite a lot using provisioning and deployments via containerized setups. And the last thing that I didn't mention so clearly is that we're using Docker technologies. There are safeguards, several kinds of safeguards. So I mentioned health check. So if you add a health check for the services and you have a policy to validate that health checks are present and correctly configured, it's possible to give superpowers to the developers that they can be responsible and manage their own services on top of Docker Enterprise. All right. And that was all. So I recommend to go and check out those sessions if you want to know more about container deployments. So, questions? 2 minutes. Okay. Yes?
There we go. And it should be on now.
We have the same kind of setup you have with console and everything. Do you have any architectural committee for setting standards for the routes, the environment variables in your Docker compose files? Yeah.
So we use templates. We don't. We have built our own templates, and depending on the all, like on the keynote, the Docker desktop has, but using these Node.js modules, and we what we basically require are Docker files, Docker Compose files, and there is also metadata for a repository what we check where to deploy, obviously.
No, do you set like rules for like naming the labels so they can be service discoverable?
Yes, so our services are discoverable in console. So using this third-party utility Glider Labs registrator, which listens events of a Docker engine and sends payloads to console API. And for what's my favorite part about external service discovery is that when I need to upgrade or start using new Docker Enterprise, which may have breaking changes, so I can't do like in-place upgrades. I just provision new cluster, start deploying workloads on the new one, and so everything is discoverable via console, and I don't have to do any other configurations for it.
We have time for one more question.
Just a quick question. Before you deploy those sandbox, developer deploy that code with their local. Is that correct?
Okay, I didn't hear that question very well.
Okay, my question is, before you deploy your code to sandbox, before that, developer deploy that code in their local. Is that correct?
So we go through, usually we test on local environment.
Yes. In the local environment, for example, if I have for microservice deployment, if I have 20 to 30 service, if I have a Kafka service, if I have like a Postgres Redis service, my Mac will not enough resource to handle this service. How can we do?
So we use Docker Desktop. So Docker for Mac is actually running, and with shell script to run the Docker Compose commands to deploy those required services which are needed. And for our case, we only have like 2 templates, one for developers and one for infrastructure guys. And the second template is very simple. We just deploy console and registrator, and we just run services in container.
Okay, thanks. Between the sandbox to the staging, you have policy control with a gated to staging environment. With that policy, how can you use in Jenkins realize how can you really realize that the control, the code goes through to the staging?
So we add rules into GitHub. For this demonstration, I didn't, for example, show, but you can actually add some mandatory checks. For example, code linting is done, and we get to send the report to GitHub before it actually does. For example, if there are like code can't be merged into the master when we get this error from GitHub, and our deployment orchestrator will stop the deployment.
Okay, thank you.
Any other questions?
I think we have to wrap it up.
All right.
So, I mean, if there's any more questions, they can ask you outside.
So if you have more questions, we can talk outside.
Thank you, Rona.
Yeah.